to test the hypothesis. Why can't you do it just by looking at mean or any other statistics that is of interest? Right? Our statistics of interest is say mean. But we just can't tell whether the two means are different. So what is that? Why can't we say that based on sample research? One. Two is, why do we need to have error type 1? Because error type 1 is determined by the researcher. Okay? So what is the level of significance? And why do we need it? This level of significance. Okay? We will be looking at that. We will also be looking at sample size determination based on statistical formula. Right? So these three things I will be doing on board. Right? Just to show you how things actually work. Now, if you look at this is population distribution. Okay, our variable of interest. Say our variable of interest is repurchase intention. That दोबारा से वही प्रोडक्ट या वही ब्रांड खरीदना चाहते हैं लोग. तो कितने लोग खरीदना चाहते हैं? What is the probability that a individual from population? Okay, what is the probability, or how much is the probability that people would purchase? Right? So say this is the purchase intention. And this is the probability. What is the probability that purchase intention would be very low, or what is the probability that purchase intention would be very high? The same example can be in, say, blood pressure, hypertension, whatever variable of interest is there, right? So generally you would find that the population distribution would be, ये थोड़ा skewed दिख रहा है, but then it will be balanced. Okay. And this is mu is equal to this mean. This central part is the mean value, and the probability as you go away from mean, you find probability would reduce. Okay, this is says population distribution. In population, what is the mean purchase intention? A mean purchase intention would have maximum probability also, and the probability of the intention, purchase intention being lower than that and higher than that would be lower. Okay. Now, if you move from this to a sample distribution, say we have taken a sample out of this population. This population size may be whatever number, and I will come back to that number again. But then right now, whatever is the number of this population, we have drawn a sample from this side, this population, and say sample size is 100. Now, even the sample would have similar distribution. That means, but this would be replaced now by X bar. Mean would be replaced by X bar. Right? This is sample distribution. Say would be say similar. And why it would be similar, I will come back. Right? Now, these two distributions generally we are understood correctly because people can understand easily that if you are measuring a variable, what is the probability that the value would be mean equal to mean, highest number of people would be nearer mean, and as you go away from the mean, lower and lower number of people would be there. Now that is generally understood by everyone. Now next is, when we draw a sample from a population, why can't we directly say, when say we have drawn two samples, one sample is of female respondents, the other sample is of male respondents, and we are looking at again purchase intention, right? Or we are looking at say blood pressure of both groups. Why can't we directly say if we take mean blood pressure or mean purchase intention, why can't we say that the two groups are different? Say one has, say I am talking about purchase intention, so if you are measuring in purchase intention on 10 statements and the scale used is 1 to 5. So maximum score would be 50. Right? Say mean score is say 35. Mean purchase intention is 35. And mean purchase intention of the population was say 30. Or another group x1 bar, x2 bar was equal to 30. Forget about population. Now can we say that these two means are different? Because without carrying out any analysis, and if we are taking, this is the mean of sample, we will not be able to say whether these two means are different. Right? And why? What is the reason? Now I am coming to sampling distribution. Now if I draw sample from this population, say this is a population distribution, and I draw sample, number of samples from this population. First part is how many samples can I draw? Suppose this population size n is, like say in this workshop, the total number of respondents are say 100. I want to draw a sample of 50. How many samples can I draw? Somebody said 2. Anybody else would like to try? N, C, N. N, C, N. N, C, N. Or popularly the formula is known as NCR. Popularly the formula is known as NCR. It is the same formula that would apply here. And if you apply this formula, how do you expand this formula? N factorial divided by n factorial n minus n factorial. Correct? Now, if this is 100 factorial divided by n is 50 multiplied by 50 factorial, what would be the value? This 100 factorial is 100 multiplied by 99 multiplied by 98 up to 1. This is 50 multiplied by 49 up to 1, and this is again 50 multiplied by 49 up to 1. This value will be very, very large, in millions. Right? When you calculate this value, the value would come out to be very, very large. Now, if this population size was only 100, this is a limited population, very, very limited population. Sample size we have drawn is of 50, half of the population size. And there also we can draw millions of samples. So if you can draw those many samples out of just 100, then the number of samples that you can draw from a population of say 14 lakh, 15 lakh at Gwalior, infinite. Even if you take sample size of 500. Right? So what I am trying to say is that sampling distribution, that means if you draw mean of the samples, that will also have the same distribution. It will also, and even if say a population of 100 may not be normally distributed, a sample of 50 may not be normally distributed, but when you take mean of this sample and you draw millions of such samples and draw the probability curve, it will always be normally distributed because the number of samples are very, very large. Right? So therefore sampling distribution generally is always normally distributed, even if the population is not normally distributed and the sample is also not normally distributed. then also sampling distribution would be normal distribution. Now, suppose that means sampling distribution will also look like this. Now I am taking, this is sample 1, okay, this is sample 2, this is sample 3, this is sample x bar, okay, 1, x bar 2, sample x 2, sample x bar 3, because I am plotting means, okay, like that. These are the samples, number of samples that can be drawn. Now if it is normally distributed, some samples would have minus infinite value and some samples would have plus infinite value. That means if I don't draw some limits, I can never say whatever is the value of the steady state. That means purchase intention if you were measuring or blood pressure if you were measuring. That any value is possible. And if it is any value possible, that means no value would be outside this curve. And if no value is outside this curve, every value would have some probability. Right? That means we can't take a decision whether the two groups are different on the statistic of interest. Statistic of interest in this case is mean. So on the basis of mean, the two groups are different. You can never make a decision unless you draw some limits to this curve. That means we will have to accept some error and draw two limits, and that is what is called level of significance. One limit we might draw this side if we are having two-sided or two-way analysis, two-tailed test. If we are having two-tailed, then we can draw two limits, one this side, one the other side. And the area outside these two limits is the level of significance. The sum of the two areas, if it is two-tailed, and if it is one-tailed, then in that tail, the area will be equal to level of significance. Now, if in our case, if we take level of significance as 5%, then the area covered will be 2.5% this side and 2.5% this side. Or in terms of fraction, 0.025 and 0.025 this side. Now that is the error we are accepting, type 1 error. That means we are rejecting the hypothesis when hypothesis is true. That means hypothesis might be indicating that this sample is part of this population and we will reject. No, this is not part of this. But what we have done, we have devised a method of testing. That if any value is below this, it will be outside, it will be rejected. Any value above this would also be rejected. That means that sample will not be considered part of this population. So we have devised the method of, say, testing the hypothesis by putting those two limits or by accepting some error. That is 5% level of significance or 1% level of significance. Generally, these are the two errors that are generally used, 1% or 5% level of significance. And in two tails, they are divided into two tails, and in one tail, they are into one tail. Now, why should not we decide this as the minimum? This level of significance, we should decide minimum so that the first type 1 error is minimized. And that should be 1%, and if it is possible, less than 1%. So that the error is minimized. It is rational to think, isn't it? Now, instead of, this was one group. Say, from this total population, I divided this population into two groups. One group of female respondents, the other group male respondents. And I had drawn two samples from this. Okay? Or number of samples can be drawn from female, number of samples can be drawn from male population. Right? So, suppose this is the distribution of, say, male population. And I draw a distribution for female population. And I want to see whether the difference between the two is significant. Now, I am coming to type 2 error. Okay, I am trying to make a ground for type 2 error. So as you reduce type 1 error, you would find here, you would see here that type 2 error would increase. Okay, now let's see. Say the other distribution is like that, and this is the mean. Okay, and now this is the mean, mu, this is the population mean, because there are number of samples that have been drawn, so this is the population mean, and there is a population mean here also. Mu1, mu2. Alright. Now suppose level of significance we have decided was 5%. Okay? So, for 5%, say this was the level this side and this was it. Okay? If you look at, if I had two colors, it would have been easier to distinguish, but I am making one thicker. Okay? This is the distribution, left side. This is right side distribution coming. This is the left tail of the right side distribution, and this is the right tail of left side distribution. I want to find out whether the two populations, male and female populations, differ in terms of, say, understanding of research methodology. Okay? I have collected data and I want to see whether they differ. Right? Now, I have decided 5% level of significance. Now, 5% level I have decided, then the cutoff line for the right side is this and for left side is this. Okay, now there is a gap between the two. That means the two populations differ significantly. If there is no overlap, okay, if there is no overlap in acceptance area, now this is the acceptance area. Area of acceptance. This is the area of acceptance for the male population, and this is the area of acceptance for the male population. Is there any overlap on the acceptance area? No. If there is no overlap, that means what we will say, the two groups are different. That means the understanding of research methodology of male group and female group are significantly different. Okay? Significantly different. Now suppose I decided that no, I will test it on 1% level of significance. Okay? Instead of 5%, same distribution is there because male-female respondents are same. Their research methodology knowledge has not changed. I am doing the same on same population, the test, and this time instead of 5%, I have decided 1%. Now what is going to happen? The cutoff line, this cutoff will move to the right, and this cutoff will move to the left. Now, that means this cutoff might go to this place, and this cutoff might come there. Now this acceptance, the left side acceptance has gone up to there, and the right side acceptance has come up to here. There is an overlap now. That means now there is no difference between the two populations. Now it says there is no difference between the populations, and say originally there was a difference between the two populations. Now what we have done now? We have accepted the hypothesis when the hypothesis was incorrect. We have accepted the hypothesis when the hypothesis was incorrect. That is type 2 error. So, as you reduce type 1 error, that means from 5% when we moved to 1%, we found that we increased the type 2 error. Okay? So, I just wanted to tell you this, that why so many of us actually use 5% level of significance, and we don't try and minimize type 1 error and go to 1% level of significance, or use 10% level of significance, the other way around. Right? It is not that there is no study that you would find which will have 10% level of significance or 1% level of significance. But the number of such studies are very, very rare. Right? And the reason is that you would like to balance between the two errors, type 1 and type 2 error. Now we have understood that when we want to test hypothesis, we would have to take recourse to statistical test. When the statistical test tells us that the difference is significant, then only we can say that two groups differ. And if it tells us that the difference is not significant, we will have to say that the two groups are similar. The two groups do not differ. Because we are doing this on sample. Had it been on population, then we would have just said based on mean that yes, two means differ. But since we are testing it on the sample and the sample distribution would be like that, we are not able to say whether the two means are significantly different. Alright, so this part is over. Now I will be using similar sampling distribution and work out formula for our sample size. Alright, this is sampling distribution. If this is the mean, that is population mean, over R, that is x bar, x level bar. It is x level bar and mu will be same. Okay, mean of all the means of samples and the population mean are going to be overlapping. They are going to be same. Now, if we move up to the left side cutoff line, there is an acceptance area this side and there is an acceptance area the other side. Okay. Now, how much is this area? Z standard deviation or ZS in case of if we are taking sample standard deviation equal to population standard deviation, isn't it? It is equal to Z multiplied by the standard deviation. Standard error, in fact, ZSE, not standard deviation, standard error. Z multiplied by the standard error. Z multiplied by the standard deviation, in fact. Now, if you convert that into standard error is equal to S divided by root 10. It will be S. SE is equal to S divided by and root 10. That means I can replace SE by S divided by root 10, where S is the standard deviation. SD of sample. And N is sample size. Right? So it will become error is equal to, this is called error because variance from the population mean is called error. And this will be accepted error. So accepted error is equal to ZSC, which is equal to Z multiplied by S divided by and root 10. Okay? So error is equal to the maximum error that we are accepting, either side, is equal to this. And how much error is acceptable to us? As a sponsor, suppose there is a sponsoring organization and that tells us that this is the error that is acceptable to me. So one side there will be error that is acceptable based on the sampling distribution. The other side there is an error that is acceptable to the sponsoring organization or the evaluating people. Okay? So therefore that is the acceptable error. Error accepted or acceptable error is equal to small e. Okay? Large E is for, say, this error that is there in the sampling distribution because of sampling distribution, and this is acceptable error. Now, or if these are two equal, I mean, they have to be equal if you want to do a good research. That means your sampling error should not be more than the acceptable error. Okay, sampling error should not be more than the acceptable error. So therefore, if I convert this now, that means I can have small e now because it should be at least equal. That means acceptable error should not be less than the actual sampling error. Okay, your sampling error should be smaller or equal at the most. So that is the maximum error that we can accept, and maximum error would lead to minimum sample size. Okay, so we are working a minimum sample size formula, not maximum sample size formula. So E is equal to Z multiplied by S by √n. Now let's take cross multiplication. E multiplied by √n is equal to Z multiplied by S. Now if I convert it into n, तो square हो जाएगा. E square n is equal to Z square multiplied by S square, and n is equal to Z square S square by E square, or I can say simply ZS by E whole square. So this is the formula for sample size. This is the minimum sample that would be acceptable, because the sponsoring organization or evaluating organization will not accept more error than this, and smaller the sample, more the error. That means this would be the small minimum sample size that would be acceptable to the sponsoring organization. Now, if I work out the problem, see, just by looking at formula, you can't understand how you work out. What would be the sample size? Let's work out a problem so that we know how to work it out. Suppose we are doing a study on knowledge on research methodology. We are using say 15 statements, and scale is 1 to 5. Maximum value that we can get is 75. Okay, maximum value that we can get is 75. So we are ready to accept an error in this case of 5. Okay, that 5 score this side, that side would not make a difference. Right? So that means the error acceptable to us is 5. Now let's work out what would be the sample size. Say and sample size might be for 1% level of significance and 5% would be different. Okay, let's work out for 5% level of significance. What is the value of Z at 5% level of significance? 5% level of significance, what is the value of Z? It is fixed. It is depending upon the level of significance, it is fixed. At 5% is 1.96. At 5% level, Z is equal to 1.96. Okay, it's a fixed value. At 1% it is 2.58. 2.58. Okay, at 1% level of significance. So we are working out at 5% level of significance. So we will see. Now 1.96. That means, according to our formula, right, n is equal to Zs by E square. So Z is 1.96 square multiplied by S, standard deviation. Now suppose we worked out, we have taken a small sample, okay, we have carried out a survey in a small sample, and that indicated that our standard deviation is say 10. S is 10. So what will be the sample size now? Z is 1.96 square. Now 10 square divided by E is 5. Right? So it is 3.81. Yeah, 3.84 multiplied by 100 divided by 5. 1.96 square.
E square. 25.
25. Right. E square, yes. 25. Correct. So, what is the sample size? 16. Minimum sample size is 16. If any one of these, either E or S change, sample size will change. And if we change the level of significance again, the sample size will change. If we take 1% level of significance, now this value will become 2.58. So this will be 2.58 squared. So what will be the sample size then? 2.58 square multiplied by 10 square divided by 25 e square. So how much is this? 2.58 is 7 point something. Multiplied by 4, it will be around 28. So from 16 it has gone to 28 as soon as it will change level of significance. So if we want to reduce the first or error type 1, we need to take larger sample. Okay? So we've seen, and if this E goes to 2 instead of 5, our level of the error accepted to us becomes 2. So what will happen? This will become 4. And now, what is the sample size? 25 multiplied by 7. That means 175. Sample size would become 175. As soon as you want more accuracy, you need to have larger sample. Larger the accuracy required, larger the sample. Now, I have worked out, and we know the formula. Can we decide the sample size? And why not? This is a proper statistical formula. There is no doubt about it. Still, are we able to work out the sample size? No. Reason one is that what is the accepted level of what is the accepted error? When we are doing say a research study on our own, it is very difficult to say this is the accepted error. Right? It is not possible to say that this is the accepted error. Right? Because whatever error you say it is accepted, and 10 others would raise me, sorry, this is too high. Okay? 1. 2 is, generally people say that your standard deviation divided by 10 is the ideal choice. Generally people say, in world over, standard deviation divided by 10 is the ideal error accepted. Okay, fine. You have decided E is 10, 10% of S. That means, now if it is 10%, that means E squared, S squared by E squared. What will be S squared by E squared? 10% means 0.01. That means multiplied by 100. S multiplied by 100. Sample size would become S multiplied by 100. Right? And generally the standard deviations are in numbers 5, 6, 10 multiplied by 100 becomes very large, and multiplied by Z square also. And Z we can fix because we have decided a level of significance. But the sample size becomes very large because the second problem comes. Okay, one is fixing E. Second problem comes fixing of standard deviation. When you have not started carrying out research, how do you know what will be the standard deviation? You need to decide sample size before you start actually working on your study, isn't it? Or based on your exploratory part, that is say small sample study, pilot study that we got. Now, if we decide based on pilot study and a particular sample size, standard deviation is worked out. Now, this will give you a sample size that is far more than the actual sample size that is going to be needed, because smaller the sample, higher the standard deviation. Right? So, you can use this through an iterative process. That means initially you work out the sample size based on the pilot study, and then you collect 50% data or 25% data, and then again work out the sample size based on the new standard deviation. And you will find that the sample size would have come down drastically from the pilot study sample size that was worked out based on pilot study. Right? So, as you collect data, you continue working on the standard deviation, continue working on your sample size, till the time the sample is complete. So that is a possibility that you can use. So at least S is not a problem there. E is still a problem, and this 10% is not digested by a number of people in India. Right? In Ross work, there are people who accept this 10% of standard deviation, but it is very, very difficult to digest because the sample sizes become very, very large if you keep the 10. And the other way around, this thumb rule shall all come from this, that multiplied by 10. And that is very, that is acceptable to us because the sample sizes worked out based on that actually come out to be in the range of 500 or lesser. So we are comfortable with that. Therefore, generally people would quote thumb rule and would not go for this statistical formula. Alright, but then nothing stops you going for that. I have worked out the formula for you. I have told you how to go for it. You can use it. Because there, no questions can be asked. Thumb rule also, nowadays they are acceptable rules, no question can be asked. If you multiply it by 10, really, then nobody will ask you. But if you start telling, no, one author said multiplied by 5, so I have used that, that is not acceptable. Because you would find number of studies where they have used the sample size multiplied by 5 in Western countries also. And they have justified their sample size based on multiplied by 10. But we should continue using multiplied by 10. Because if you go for structural equation modeling or confirmatory factor analysis, it will not work if it is multiplied by 10. You have to use multiplied by 10. Right. So one part we've done. How to test hypothesis? What is level of significance? What is acceptance area? We have also done that. Now this level of significance is also called alpha. Okay? This level of significance is also called alpha. So alpha is same, that is equivalent to your level of significance. So if you have selected 5% level of significance, alpha is type 1 error.